Hi everyone, welcome back to another video. So in this video we are gonna discuss binary search on answer space, and before moving into how binary search works, we will see why binary search works. Okay, so we will solve this concept using one problem, which is very famous problem in Codeforces, hamburgers. So the problem statement reads like Polycarpus loves hamburgers very much. He especially adores the hamburgers which he makes with his own hands. Polycarpus thinks that there are only three decent ingredients to make hamburgers from: a bread, sausage, and cheese. He writes down the recipe of his favorite Lee hamburger de Polycarpus as a string of B, S, and C. B stands for bread, S for sausage, and C for cheese. The ingredients in the recipe go from bottom to top. For example, recipe BSCBS represents the hamburger where the ingredients go from bottom to top as bread, sausage, and cheese, bread and sausage again. And after that, Polycarpus has NB pieces of bread, NS pieces of sausage, and NC pieces of cheese in the kitchen. Besides, the shop nearly has all three ingredients. The prices are PB rubles for a piece of bread, PS for a piece of sausage, and PC for a piece of cheese. Now Polycarpus has R rubles and he is ready to shop on them. What maximum number of hamburgers can he cook? You can assume that the Polycarpus cannot break or slice any pieces of bread, sausage, or cheese. Besides, the shop has an unlimited number of pieces of each ingredient. Okay, so basically, what problem statement means here is that Polycarpus loves hamburgers very much. Okay, and especially he loves hamburger which he make on his own. Now to make one hamburger, he has written some recipe. So the recipe here is like BSCBS. Okay, so BSCBS. So this string means that on the very first top of hamburger contains a bread, then a sausage, and then cheese, then again bread, and sausage. Okay, so sausage and bread looks very similar. Okay, this is bread, this is sausage, bread, sausage. So to make one hamburger, how many breads he need? He needs two bread. Okay, two sausages and one cheese, right? To make a hamburger whose recipe reads like BSCBS. Fine. Now Polycarpus has R rivers and he is ready to shop on them. What maximum number of hamburgers can he cook? Okay, so Polycarpus initially have some pieces of breads, sausage, and cheese with him. Okay, so initially Polycarpus have, okay, NB breads, NS sausage, and NC cheese. Okay, and along with all these three ingredients, he has R rubles with him. Means ruble is a currency. So he has a shop nearby. In that shop, one bread cost PB for one bread, PS for one sausage, and PC for one piece of cheese. Okay, now he wants to find out, okay, he wants to find out what maximum number of hamburgers can he cook. We can assume that the shop have unlimited number of bread, sausage, and cheese in the shop, but we have very limited money, which is our ruble. Okay, now if you will see the constraint, okay, so the number of bread sauces here is very finite, like it can go up to 100, and the prices of bread sauces can also go up to 100 only. The ruble, the money which he have is 10 to the power 12. Okay, 10 to the power 12. Now the brute force approach to solve this. Okay, the brute force approach to solve this could be, we will start we will start make from one burger. Okay, from one burger until we can make burgers which will not go up to infinite. Basically we will stop somewhere. Okay, so we can do is, for one burger we can count that how many breads we need. Okay, let's say breads we need are x. Y is the number of sauces we need, and z is the number of cheese which is required to make one hamburger. Okay, now when you will run this for loop from one burger to up to so on, somewhere this for loop will stop. So to make, let's say, uh, let's say one variable we can assume m. Okay, to make m hamburgers. Okay, how many breads do you need? You need x into m breads, you need y into m sausage, and z into z in sorry z into m cheese. Okay, so we will check in this for loop, in this brute force approach. So we initially have some pieces of bread with us. Okay, so the required bread which we need to buy is xm minus b. Okay, not b, nb. Nb is the number of bread we have. Okay, so xm minus nb into pb, which is price for one bread is pb, so price for this many bread is this one times pb. Okay, similarly we can find for sausage into ps, and similarly we can find for cheese. Okay, pc. So we can run this for loop, but the problem here is that your ruble can go up to 1812. Okay, so if we assume that the cost of one burger is which is basically pb is 1 rupees, 1 rubles. Okay, currency here is ruble, ps is 1 and pc is 1. So if we assume that cost of one burger, one sausage and one cheese is 1 rupee each, so our loop might run from 1 to 10 to the power approx 12. Okay, because your ruble can go up to 10 to the power 12, but we are not allowed these many operations, right? So we need to find one efficient approach. Okay, now what efficient approach can we think of? What that could be? So in cp, whenever you will read the word maximum or minimum, so always try to think of binary search. Why binary search, right? So we know if we will start from 1. Okay, let's say this is the graph, number of hamburgers we can make. Okay, so let's say number of hamburgers we can make is a graph which looks like this, right? So obviously there will be a point. Let's say this point is let's say this point is o. Okay, so obviously there will be a point o up to which we can make these many hamburgers. After that we cannot make. After that we will have like shortage of rubles to make hamburgers. So what we can do is we can like binary search. What is binary search? What was for array? You know, we have one sorted array and we need some target. So we'll assume a mid. We check the mid, whether the mid is less than target or smaller than, and according to that we use to adjust our answer space. Similarly, if you will see here, okay, so this is this is a monotonic function of number of hamburgers which we can make. It is increasing this way, right? So unlike binary search, we can also use here binary search on answer space. How? So let's say the least number of hamburgers, the minimum number of hamburgers we can make is 0. How? Let's say we have one pieces of breads with us, and the number of breads which hamburger requires is 2, sauces 2 and cheese 2, and we have let's say 1 ruble only, and price of these is also 2, 2, 2. So you can see that we cannot make even one hamburger using these many breads and these rubles. Okay, so in that case the number of hamburgers we can make is 0. In another case what we can see is that we have 1 e 12 rubles. Okay, so we can make like almost 1 e 12 hamburgers, plus we initially have breads, chicken, sausage with us in amount of 100. So we can make up to 1 e 12 plus 100 hamburgers. This is our maximum capacity. Sorry, so this is our maximum capacity, this is our minimum capacity. Now we know that up to some point, up to this point O, we can always make hamburgers. We can make these many hamburgers, these many, but we cannot make these many hamburgers. So we will run a binary search function here. So how that binary search will look like? So this is our start point. Okay, this is our midpoint. Sorry, not the mid, this is our end point. Tick. So start point is 0 and midpoint is 1 e 12 plus 100. So we will assume of like binary search. What we do, we take a function mid is start plus end by 2. Okay, now we will check this mid, we will assume that this mid is our number of hamburgers which we have to make. Okay, we'll check for that, can we make this number of hamburgers. So for to make mid number of hamburgers, how many breads we need, how many sausages we need, and how many chickens we need, it will be mid into, like here the m will be replaced by mid, so x into mid, y into mid, and z into mid. Also we have some hamburgers with us, some ingredients with us, so breads, sausage, and chicken. So we'll subtract that and we will calculate the amount which we need to pay. Now finally, let's say initially we had like our money, we had ruble money. Okay, so we will use this money to make mid number of hamburgers. Now after making mid hamburgers, we will check that our money is greater than equal to 0 or not. If our money is greater than equal to 0, it means that we either spent all of our money to make mid hamburgers, or we are spared with some more money, but we still made mid hamburgers. Okay, so if we are still left out with some money or no money, our money didn't go negative. In that case, it means that we can make up to mid hamburgers. So let's say if this was the point mid, so we can make hamburgers up to this range. So now this range will be discarded. This is what we used to do in binary search now. We check on a range, and the number of the range which we are able to satisfy, which the range which is able to satisfy our answer, we discard that range and we check further. So if our money is greater than equal to 0, it means we can make up to mid number of hamburgers. So what now our search answer space will look like? Our start will shift here, mid plus 1, and our end will stay same. So we will update our answer. Okay, answer we will update, and we will update our range also. So now our start will be mid plus 1. Okay, else case will be our money money that became negative. Money became negative means if we tried making mid number of hamburgers, we had shortage of money. We cannot make mid number of hamburgers with this money. That's why our money became negative. So if our money became negative means, let's say if our mid was somewhere here, so obviously we cannot make these many hamburgers. So our money will go into negative. We will fall short of money. So in that case, what we will do? We will discard this range now. Okay, it means if we cannot make hamburgers up to this point, obviously we cannot make hamburgers further this point. So this range will be discarded and our end will shift here and our start will stay the same. So what else condition will look like? Else we will change our mid. So end will be changed by mid. Now since this is a binary search function, our answer space is reducing by half every time. The time complexity will be log of n. Okay, so 1 e 12 log is very small number. It will be like around But 50 to 60. So now this will pass. We got rid of that for loop and we did our calculation in very short period of time. So this is how binary search on answer space will look like. Your code will always stay the same. Okay, it is like binary search on searching element in array only. You can see that here also we are having mid to if else conditions. Only these things will change. Okay, the operation will change in every binary search code. Rest of the things are same. So, and how you will know that one question requires binary search? Whenever you will see maximum of something or minimum of something, the first thing which should come to your mind should be binary search. Why maximum and minimum? So the question asked maximum and minimum, reason being, as I told, we can make hamburgers up to this O point, but we need maximum. So maximum is O. And how this maximum will come? This maximum will come from a range, okay, by discarding range in our binary search. That's why whenever you will see maximum or minimum, always go for binary search. If we will see the code for this question, so here is the string s, which is the recipe. This is your recipe of hamburger. Okay, now we took the input of ns, nb, ns and nc, which are the number of bread, sausage and cheese with us. This is the price of bread, sausage and cheese, and this is the ruble we have initially. Now we will count how many burgers, sausage and cheese is required to make one hamburger. Okay, so if si is equal to b, then count burger plus similarly sausage and cheese. Now our binary search range, which is low is 0 and high is ruble plus 100. So this is the range of our initial answer space. Initially our answer is initialized with low, means initially we are assuming that the answer is 0. Now while low is less than equal to high, we calculated mid. Now we are calculating here a number of burger, sausage and cheese required for, sorry I wrote burger here, it was supposed to be bread. So number of bread, sausage and cheese required to make mid hamburgers. Okay, and we have initially money as ruble. Now we are subtracting, this is what I told number of bread required minus nb, number of bread we have, into pb, price of one bread. So this thing can go in negative. Let's say we require only 2 burgers to make let's say we require only 2 bread to make one hamburger, but we have like 100 breads with us. In that case this value can go negative. Okay, so to avoid that negative, we are subtracting maximum of 0 comma this. Okay, similarly we are doing for sausage and cheese. Now if our money is greater than or equal to 0, which means that we can make mid hamburgers, so in that case we are updating our answer to answer is equal to maximum of answer comma mid, and we are reducing our answer space, low is equal to mid plus 1. Else we are reducing again our answer space, we are shifting our high to mid minus 1, and at last we need to see out answer. So let's try to submit this code. It will be accepted only. I submitted this code 5 minutes ago. Okay, so this below, this is the same code, right? So yeah, this got submitted. So that's it for this video. I hope this will make your concept clear on binary search. Let's look forward for more videos. If you have any suggestions for me, please drop it into the comment section. And I tried making this video in English, even though I'm not comfortable in English that much. Hindi is my mother language, Bhojpuri is more mother language, but still let's try. Okay, bye bye, have a nice day.